So that's sine theta opposite over hypotenuse. So we already know that the opposite, since the angle is against the horizon, the opposite will be the vertical value. So that's negative 1.09 times 10 to the 9th over the hypotenuse, which we don't know. So that's still h. Then we know that theta is 14. This is sine 14.28795313. So now let's isolate h, and we will get h is equals to negative 1.09 times 10 to the 9th over sine 14.28795313. So then let's simplify that, and we will get the answer of negative 4.42 times 10 to the 9th. So this is now our answer. So if we draw that on a Cartesian plane, we will get this. So this is the vertical value which we computed ganina. So that this is the 1.09 times 10 to the 9th. Well, this one is the negative 4.28 times 10 to the 9th. So what we just computed will be the middle value between them. So according to our computations, the angle against the horizon to this one is 14.28 something. Then the value that we just computed is this vertical. So that's negative 4.42 times 10 to the 9th. If you don't want to use SOHCAHTOA for finding this value, you can also use Pythagorean. So I'll just demonstrate that in case you prefer using Pythagorean, which is actually what Sir uses. So we can use C is equals to square root of negative 4.28 times 10 to the 9th squared plus negative 1.09 times 10 to the 9th squared. So if you input that into calculator, you just get the same answer, which is 4.42 times 10 to the 9th. It's just the same. The difference is just in how you get it. So that is it, and let's now try solving another problem. So this time, still a rectangle. We now have A, B, C, and D. A is positive 5, B is negative 12, C is positive 6, and D is negative 0.1. So in this case, we will be looking into the forces exerted on A. So let's start with the forces exerted by B on A. Okay, so let's input values using the same formula. So that's 9 times 10 to the 9. So that's Q1 is A, so that is positive 5. So that's 5. Then K2 is B, so that's negative 12. Over the distance between the two of them is 1, so that is 1 squared. So when you simplify that, we will get 9 times 10 to the 9th, times 60, which will give us the answer 5.4 times 10 to the 11th. So going back to the figure, we can see that A is positive while B is negative, so they will be attracted towards one another. So A will be going downwards towards B. So this will have the value of down. Okay, next, let's go on the force exerted by let's go first with D, since A has D is just there, so it's easier compared to C, which is slanting. So let's go first with the forces exerted by D on A. So we have 9 times 10 to the 9th, then A, which is 5, then D, which is negative 0.1, over the distance between them is, I want to focus. So that's 5. So we'll get 5 squared, and that we'll get the answer 1.8 times 10 to the 8th. And looking at the figure, we can see that A and D have opposite signs, so they will be going towards each other. So A will be going to the right. So that is right. Okay, so now we'll be solving for C. So first we need to look for that diagonal, that diagonal line there. So let's use Pythagorean. So that C is equals to 5 squared plus 1 squared. So let's give us square root of 26. So now let's focus on C, forces on C on A. So we'll have 9 times 10 to the 9th, and then A, which is 5, then C, which is positive 6, then the distance is square root of 26 squared. So the reason I didn't find the value of square root of 26 is that R will just be squared after, so instead of having a value that has a lot of decimals, let's just use square root of 26, because this will just get cancelled by the square when we input the values in the formula. So now let's simplify that, and we will get 9 times 10 to the 9th times 30 over 26, which will give us the answer 1.0385 times 10 to the 10th. So C and A have the same sign, they're both positive, so they'll be going away from each other. So meaning A will be going up left, in an up left direction. So let's place it here, up, left. So now let's look for the horizontal and vertical components of the force C. Okay, so so the vertical component will have the force C is 1.0385 times 10 to the 10th. Then vertical, so we will use sine. Okay, we need to look for theta first. So let's look for theta here. So again, we'll use tan theta is equals to opposite over adjacent. So manipulate this formula and we get theta is equals to tan -1 opposite over adjacent. So again, the angle that we'll be looking for is one that is against the horizon. So meaning horizon, there, this one. Sorry. Or this, so if this you chose this horizon, so this one. So if we use an angle that's against the horizon, our opposite will always be the vertical side. So let's put that here. So we have tan -1 opposite, which is 1, then adjacent, which is 5, and this will give us answer of 11.309932474. So that is our given angle. So now we can place it here. So that's sine 11.309932474. So this will give us the answer of 1.1745 times 10 to the 11th. So since this is up, so that's just positive. Okay, then the horizontal component will be 1 times 0.385. So remember, this is the value, the diagonal value of force C on A. So that's times 10. So this is horizontal, so meaning this will be adjacent. So we'll use cosine. So that's cosine 11.309932474, giving us the answer of 0183 times 10 to the 10th. So now that we have the horizontal and vertical components of the force C, we can now make a table again, and let's find the resultant forces. So let's make a table. That's vertical forces and horizontal forces. So we'll have B, C, and D. So for B, if you recall, the value we have is 5.4 times 10 to the 11th down. So let's place that here, down, so vertical. So that's 5.4 times 10 to the 11th. So it has 0 for horizontal. Then for C, we have 1.8 times 10 to the 8th right. So let's place that here. So that's this one is down, right? So this is negative. So this to the right, so this is positive. It's 1.8 times 10 to the 8. And that's 0 for vertical. Then for D, we have a vertical is 1.1745 times 10 to the 11th, while our horizontal, so this is up, so it's this positive. Our horizontal is 1.0183 times 10 to the 10th, which is, it's going left, right? It is going to the left, so we will make that negative. So combining all these forces, we will get an answer of negative 4.23 times 10 to the 11, and for the horizontal we have negative 1.0003 times 10 to the 10th. So now we will look for the angle of this diagonal line. So again, we will use tan, theta, opposite, adjacent, and let's manipulate that first. So we'll get theta is equals to tan negative 1 opposite. So our opposite, since the angle will be against the horizon, our opposite will always be the vertical. So that's negative 4.23 times 10 to the 11th over our adjacent, which is the horizontal value. This one. That's negative 1.0003 times 10 to the 10th. So this will give us the answer of theta is equals to 88.6453359721. So now we can look for the hypotenuse. So as previously stated, we can use SO or Pythagorean. So I mean, you can also use ka. The important thing is that the H there. I just prefer SO. So that is sine theta is equals to opposite over hypotenuse, right? So let's manipulate that, and we'll get the formula H is equals to opposite over sine theta. So input our values. Opposite, again, opposite is the vertical value. So that's negative 4.23 times 10 to the 11th over sine theta, which is 88.645335959721. Okay, so we will get the answer. This will give us the answer of negative 4.2312 times 10 to the 11th. So now this is now our resultant force. Again, you can also use the Pythagorean theorem. It's totally fine. So we can use this negative 4.23. We'll use the horizontal. This is the horizontal and vertical components. Plus negative 1.0003 times 10 the 10th squared, and it will still give us the same answer. That's negative 4.2312 times 10 to the 11th. So yeah. So just as an additional note, when you use the Pythagorean theorem, you will actually be getting a positive value. But we need to remember that when we look at the horizontal and vertical components, both are negative. So meaning when we draw this, the vertical component will be going down and the horizontal component will be going left. So meaning the diagonal line that they will make is going this way. So it's going down left, so that should be a negative value. But the negative value is just indication that it is going down. Okay, just for anyone. That's just for clarification if any of you gets confused. Yeah, so comment your questions and clarifications, violent reactions, just comment it down below.